For years, the whole story around generative AI has been about these passive one-off tasks. You'd ask it to generate some text or create an image from a prompt. And that was kind of it. It always needed constant step-by-step human instruction.
Right. It was very much a command and response model.
Exactly. But what our sources are showing today is that we're moving completely past that early stage. We're now looking at a huge paradigm shift toward the autonomous AI agent.
Hmm.
We're talking about systems that can actually reason, plan, and then execute on multi-step goals, all without someone holding their hand.
And that's the absolute critical distinction. Our mission for this deep dive is really to look past the shiny demos.
Right.
We need to get into foundational architecture,
Mhm.
the agent ops, and the really strict security you need to take this from a cool prototype to a real production-grade system in an enterprise.
And the sources are so clear on this. An agent isn't just a language model with a script wrapped around it.
No, not at all. It's a complete integrated application. It's built for autonomous problem solving. The big technological leap is that the agent combines the model's reasoning with the practical ability to act using tools.
The brain in the hands.
Precisely.
Mm.
It can take a huge, complex goal like, say, organize the launch of our new product and then figure out the entire sequence of steps on its own.
Mhm.
That delegated autonomy is the new frontier.
Okay, so let's unpack that. I love the body analogy that the source material uses. It breaks it down into 3 core pillars for a successful agent. You have the model, which is the brain,
Mhm.
the tools, which are the hands, and then the orchestration layer, the nervous system.
Starting with the model, the brain.
Uh,
This is your central reasoning engine. And what's really crucial here is that you can't just pick a model based on some, generic academic benchmark.
no, it has to be tied to the actual business problem.
Exactly. It has to be dictated by your real-world problems, your custom metrics for latency and quality.
And I imagine that pressure to balance quality, speed, and cost, it leads directly to this idea of model routing, doesn't it?
Mm.
For a big company dealing with billions of tokens, this isn't just a nice to have, it's got to be a core economic necessity.
Oh, absolutely. You simply can't afford to run a massive, expensive frontier model like Gemini 2.5 Pro for every single task. It's not sustainable.
So you route the traffic.
You route it. You use that Pro model for the really heavy lifting, the
Mm.
complex multi-step planning, the deep reasoning.
Yeah.
But for the simpler, high-volume stuff like classifying what a user wants or writing a quick summary, you intelligently route that to a faster, cheaper model, maybe like Gemini 2.5 Flash.
Yeah.
It's all about efficiency at scale.
Okay, so that's the brain. Now let's talk about the hands, the tools. This is what actually connects the agent's brain to the real world, right? It lets it go from just thinking to actually doing.
Right.
And the sources say tools really do 2 main things. First is just retrieving information. This is huge for grounding the agent in reality. So we're talking about things like RAG, retrieval augmented generation, using vector databases or even natural language to SQL.
And that NL2 SQL function is so critical because what the agent is doing is translating its own internal thought process,
Yeah.
its plan, into a very precise, very deterministic database query.
So it's speaking the language of legacy systems.
Exactly. This is how it can safely and accurately talk to all those enterprise systems that they don't speak LLM. And by looking up the facts before it answers, it just dramatically cuts down on hallucinations.
And the second function of tools is where the real power comes in, executing actions.
Mm-hmm.
We're moving from an agent that just reads information to one that actively changes the state of the world.
That's it. This means the agent can use an existing internal API to, say, send an email.
Or update a customer record in Salesforce.
Right. Or even use a secure sandbox environment to write and execute a piece of code on the fly to get a task done. It goes from being a smart assistant to a real autonomous actor.
But for that to work reliably, the tools need a very clear set of instructions, like a contract.
Of course.
And our sources really emphasize standards here, like the Open API specification, or even newer ones like the Model Context Protocol, MCP. That gives the language model the structured framework it needs to call the tool with the right parameters every single time.
Yep.
Which brings us to the nervous system, the orchestration layer. This is the process running in the background, handling the agent's whole operational loop.
And it's handling things like memory, complex planning, and applying those advanced reasoning strategies we hear about, like chain of thought or React.
Mm-hmm.
And this layer just fundamentally redefines what the developer does. They're not a brick layer anymore. They're not writing code for every single logical step.
They become the director.
The director, I love that analogy.
Yeah, they set the scene with some high-level instructions, they pick the cast of characters, the tools and APIs, and then they provide the context.
Hmm.
What's really wild here is that the agent system itself, through this orchestration, becomes this relentless loop that's just dedicated to the art of context window curation.
That's a great way to put it. The system is constantly managing its own input context, the main goal, the facts it just found, the tools it has, the history of what it's already done.
All to optimize the model's reasoning for what it needs to do right now.
Exactly. It's managing the information diet for the model to make the best possible decision at every single turn.
And that focus on the continuous loop brings us to the practical cycle of how an agent actually works. The short version is LMs in a loop with tools, but there are really 5 fundamental steps.
Right. And the cycle always starts with step 1. Get the mission. This is the high-level goal. Something like research new market penetration strategies for the Asia region.
Okay, so then step 2 is scan the scene. The agent's orchestration layer looks around. What resources do I have? What tools can I use? Is there anything useful in my memory already?
Then you get to the core of it, step 3. Think it through. The agent looks at the mission, looks at the scene, and it comes up with a multi-step plan. It might think, okay, first I need to use the market data to find key emerging economies. Then I'll use the competitor analysis tool to see what's happening in those places.
Step 4, take action. It executes just the first step of that plan. It makes the call to the market data P.
And finally, step 5, observe and iterate. The agent sees the result, the API gives it a list of target economies. That new info gets added to its memory, and the whole loop starts over at step 3. It refines the plan with this new context and takes the next action. It's a continuous think, act, observe cycle until the mission's done.
That 5-step loop think act observe is such a powerful framework, and it helps us understand this taxonomy of agentic systems that the sources lay out, showing how the complexity just scales up.
It does.
Yeah.
At the very bottom, level 0, you've got the core reasoning system, that's just the LM by itself, in a box.
So it can explain history?
It can explain history perfectly, but it's totally blind to real-time facts because it has no tools, no hands.
Then at level 1, you get the connected problem solver. This is where it gets its hands and can use that observe step.
Right.
So it can answer a real-time question because its act step is to call a search tool. It observes the result, and then it puts together the answer.
Then you jump to level 2, the strategic problem solver. This is where you see complex, multi-step planning really start to happen, and the agent has to actively manage its own context.
The coffee shop example from the sources is perfect for this. Finding a highly rated coffee shop halfway between 2 addresses, the agent doesn't just call one tool. First, it calls a maps tool to get the coordinates. But then it realizes the user said a good coffee shop. So it actively engineers the context for the next call. It refines its query to specifically look for places with at least 4 stars in that new location. That context engineering is what makes it strategic.
And from there, you get to level 3, the collaborative multi-agent system. Here, we're shifting from one powerful agent to a whole team of specialists.
So agents start treating other agents like tools.
That's it. You have a project manager agent that gets a mission, like launching Solaris headphones.
And it just delegates the work. It creates submissions for a specialist market research agent and another one for the marketing agent. I mean, it feels like companies are accidentally building these incredibly capable and probably incredibly vulnerable teams of digital employees.
It's not that far from the truth. And that leads to the ultimate stage, level 4, the self-evolving system. This kind of agent can perform meta-reasoning. It can look at its own capabilities and say, I'm missing something.
Like it needs social media monitoring.
Exactly. And so it autonomously creates a new agent, a sentiment analysis agent, to solve that problem and just integrates it into the team.
Okay, so we have this complete architectural blueprint. But now comes the really hard part, the true enterprise challenge. If these agents are, by design, probabilistic and flexible, how on earth do you guarantee security and quality and reliability when they're hooked into your core financial and customer systems?
And that's where we have to introduce this disciplined approach called Agent Ops.
Right.
Agent Ops is built from the ground up for these stochastic systems.
Right.
Traditional software testing, where you expect output it's expected, it just completely breaks down here. The agent's path is dynamic. So you have to evaluate quality differently.
And the new way to do that is using an LM as judge.
Yeah.
You basically use another powerful model to evaluate the agent's output.
To grade its homework.
Yeah. It checks for factuality, for tone, did it actually follow instructions, and it grades it against a predefined rubric and a golden data set of known good examples.
But hang on, isn't there a risk there? You're using one powerful probabilistic model to grade another one. How do you make sure the judge isn't just, rubber stamping the agent's process instead of the actual factual outcome?
That's a fantastic question, and the sources stress that the rubric and that golden data set are the critical guardrails. It's on the human engineers to curate those data sets with extreme rigor. You have to make sure the judge is trained on what a desired outcome looks like, not just a successful chain of tool calls.
Mhm.
It's a constant process of human calibration.
Okay, that makes sense. And when something does go wrong, you need a way to figure out why the agent made that specific choice.
This is where OpenTelemetry traces become absolutely essential. This isn't your standard log file.
No.
It's a super high fidelity, step-by-step recording of the agent's entire internal thought process.
It's so important because unlike with normal code, you have to trace the reasoning and the intent, not just the function call itself.
The trace shows you the exact internal monologue, which tool it picked, the parameters it generated, what it saw. It makes finding the root cause so much faster.
And of course, the most valuable data of all is always going to be human feedback. A good agent ops process has to close the loop. It captures that feedback, replicates the bug, and immediately turns that scenario into a new permanent test case in that evaluation data set. You're basically vaccinating the whole system against that class of error.
So turning to security, we hit this fundamental tension in all of agent ops. The trust trade-off. It's that constant balance between utility, giving the agent power to do useful things, and security, which means containing the risk of it going rogue or leaking data.
And to manage that trade-off, you have to start with identity. And what's fascinating from a technical standpoint is that an agent is a new class of principal. It's not a human user, and it's not a standard service account. It's something else.
A new class of principal. That sounds like a serious legal and technical line to draw. Why isn't it just another service account? Is it because it has this delegated autonomous authority to act for a person?
That's exactly it. It needs its own verifiable digital passport. Often this is done with standards like SPFE, which provides cryptographic identity for software. This verifiable identity is the bedrock. It lets you grant very specific least privilege permissions, so if an agent ever does get compromised, you can contain the blast radius instantly.
Without that strong identity, you can't really manage the risk. And as these agents start popping up everywhere across an organization, you get this problem of agent sprawl.
The only solution to sprawl is centralized governance, and that means a control plane.
A central gateway.
A central gateway, exactly. It has to be the mandatory entry point for all agentic traffic. User to agent communication, or an agent calling a tool. Everything goes through the control plane.
And by centralizing it, that gateway can enforce authentication and authorization across the board. It turns a chaotic mess into a transparent, auditable system.
Right? It ensures policies are strictly enforced, limiting what an agent can do to only what's absolutely necessary. It creates the transparency you need to audit that autonomous behavior and ensure accountability stays with the enterprise, not with the stochastic model.
What a deep dive. I mean, we've gone from a pretty abstract concept to a really detailed architectural blueprint for building these collaborative, autonomous systems that can reason and act and observe. It's clear that success here is a result of discipline engineering and real operational rigor. It's not about magic prompting.
Not at all. And if you connect all this to the bigger picture, you see that these agents are designed to evolve. They learn from experience, from traces, and especially from that human-in-the-loop feedback.
And beyond just learning from production data, our sources point to what might be the next major frontier for making them truly robust, the Agent Gym.
The Agent Gym. It's a standalone, off-production platform that uses simulation and synthetic data generators for just massive scale trial and error optimization.
So the system can basically pressure test itself against millions of scenarios.
And it can even consult with human domain experts to get over those tribal knowledge hurdles, the stuff that's not written down anywhere.
So adaptation isn't just a manual process of engineers tweaking prompts anymore. It becomes an autonomous function of the system itself, constantly training in a simulated world.
Which leaves us with a pretty important question for you to think about. As these systems gain the ability to autonomously build new agents and tools to meet business needs, how will that dynamic creation and evolution of AI capabilities fundamentally reshape the entire structure and skill set of our large organizations?